Hello, welcome back. Today I'm going to explain how to find the length of segment AB in the diagram shown. So in the figure shown, there are three congruent squares whose diagonals all intersect at the point shown in the center and whose side lengths are 12 centimeters. In the shaded region consists of 12 congruent isosceles triangles. In simplest radical form, what is the number of centimeters in the length of AB? This problem is very tricky, but if we break this down, we can solve it pretty easily. So the first thing you need to know is you need to pay attention to the angles that are given. So let's take in our first quadrilateral, which is this quadrilateral right here. I'm going to draw a bigger version of it right here. So our quadrilateral looks something like this. We know that this angle is 90 degrees, and we know that this is 150. That's because it's vertical angles with the inscribed dodecagon inside, because there is a dodecagon inside of the squares. Because one interior angle of a dodecagon is 150 degrees, we can say that this is also 150 degrees because of vertical angles. So we have 90 degrees and we have 150. And we can say that these two angles are congruent because in this figure, you can see that the squares are all spread out and turned evenly where all the angles are congruent. So if we know that they're congruent, we can do 360, which is the total interior angle sum of a quadrilateral, minus 150 minus 90. And if we do that, we get, so if we subtract that, we get 120. Now using 120, we can divide that in 2 and we get 60 degrees. So we know that these two are 60 degrees. Now that we solved for the quadrilateral, we need to look at the next part. So right next to the quadrilateral is an isosceles triangle that's shaded. We know that all the isosceles triangles are congruent, so we can just look at any of the isosceles triangles. So let me draw that same isosceles triangle on the side right here. We can say that this degrees is 30 degrees because you can see that this angle supplement is also this angle, which is the 30 degrees. Because we know that the quadrilateral's angle is 150, we can do 180 minus 150 to get 30. We also know that this top angle right here is 120 degrees. And that's because, as you can see right here, let me draw out the line. We know this angle already is 60 degrees. And because this is a straight line, we can say that 60's supplement is 120. Now, in order to find our other angle, we can say that this is 30 degrees because 1, it's an isosceles triangle, and 2, if you were to add up the given values and subtracted it by 180, you'd also get 30. So now that we find out our angles that are inside of our isosceles triangle, we can examine them now because this is the next important part. We can see that 2 of the angles are 30 and 1 of them is 120. Now, if you look really closely, you would see that 120 is double of 60. And if you were to divide this triangle in half like this, it would look something like this. So this would be a right angle. This would be 30. And if you were to bisect 120 degrees, you'd get 60. Now this triangle looks sort of familiar. It's a 30, 60, 90 triangle. And we know that for a 30, 60, 90 triangle, the short leg is x and the hypotenuse is 2x. That's all we're going to need for this problem. We don't need to know about anything about the height, and you'll see why. So this is very important. Now that we have defined that, now that we've proven that the isosceles triangle in half is a 30, 60, 90 triangle, we can find out our x value, and we can double that to find out our answer, or the length of AB. Now this is a little tricky, but if we break it down, this is pretty easy. In order to find out the height, we need to first find out this length right here, and we need to subtract that by this length right here. From base to base, we need to subtract that from the tip of the triangle to the opposite tip of the triangle. So let's first focus on finding, in this case, we'll name it A. That's our green line. And we can see that A not only touches opposite tips of the triangles, it also touches the edges of the squares. So because it touches the edges of the squares, it can give us a really big hint. Now let me draw out this shape right here. We can see that there's a triangle, another isosceles triangle that is shown. So let me draw that out right here. Because we're doing opposite triangles, because A touches opposite tips of the triangles, this is technically bisecting it. So we know that if you were to bisect or divide in half this isosceles triangle, you'd get a 30, 60, 90 triangle. And because it's a 30, 60, 90 triangle, this is 90, and we know that the larger angle is 60 degrees, other than the 90-degree angle. Now, because we know it's 60 degrees, so let me write that down over here. 60 degrees. 60 degrees complement. So if I were to put a line right here, this angle inside would be 30 degrees. And the reason I'm telling you this is because of the following. If you were to push down line A so that this tip right here would be touching the corner of the square, so it would look something like this if you were to push it down. We can say that this angle is 30 degrees because we proved that 60's complement is 30, so we can put 30 degrees there. And because we know a square's corner is 90 degrees, and this is 60 degrees because we subtract 180, we subtract 90 plus 30 by 180, and we get 60. And because every angle is 30, 60, and 90, we have ourselves another 30, 60, 90 triangle. So because we've made a triangle, we can find out the length of line A. So let's draw out that triangle on the side. We have our 30, 60, 90 triangle right here. We know that the height of the triangle, or the longest, or this length right here, it's our base in this case, is 12, because it's equivalent to the square's side length right here, 12. Now, because we know it's 12, and we know that this side is x and this side is 2x, we can use the Pythagorean Theorem to find out what x is. You know, the Pythagorean Theorem is a squared plus b squared equals c squared. A in this case can be 12, b can be x, and c can be 2x, because we're trying to find out the value of x. So it's important we have those around in parentheses. Now we can solve for x. 144 plus x squared is equal to 4x squared if we distribute the parentheses. Then we have 144 is equal to 3x squared. Divide by 3 on both sides. We get 48 is equal to x squared. So we need to find out the square root of 48. We know that we can do 16 times 3 to get 48, and we can square 16 to get 4 square root 3. So now that we know that x is equal to 4 square root 3, we can plug it in for x. We know, so let's put in x right here. 4 square root 3 is x, and to find out our hypotenuse, or line A, we have to double 4x, 4 square root 3. So we get 8 square root 3. So A is equal to 8 square root 3. So now that we know our value for A, we have to find out our value for the blue line, or in this case, I'll name it B. Let's clear some of the drawings on here so it'll be a little easier to visualize. We still have our line B, which is this. From the base of the triangle to the other base of the triangle, line B. Line B can be found in a pretty simple way. As you can see, line B is touching two parallel sides of this square right here. So there's one and there's the other parallel side. And because the side length of the square is 12, B is just simply 12. So I'll write B is equal to 12 on the side. So now that we have both values, we have our line A value. Whoops, let me do a better line. 1 second. Now that we have our line A value and our line B value, sorry, my computer glitched for a minute. Ignore this other line right here. We're just focusing on the line I drew right now. Because we have both values now, we have to subtract. So 8 square root 3 minus 12 is just that, because we can't simplify that any further. So by subtracting, we just found out this value and this value. But we only want one height of our triangle. So let's just divide that by 2. And if we do that, we get 4 square root 3 minus 6. So now that we have the height of our 30, 60, 90 triangle, which is this one right here, our blue triangle, we can plug it in for x to find out the value of AB, segment AB from the problem. So because x is equal to 4 square root 3 minus 6, and the hypotenuse is double that, we just have to do 2 times 4 square root 3 minus 6. And if we do that, we get 8 square root 3 minus 12. So that is the value of segment AB. And that is our final answer. I hope this video helped you understand this super tricky problem. You just have to use basic clues from the problem and break it down step by step. With this skill, you'll be able to solve almost every problem like this. Thank you for watching. Have a good day.